about this. And then the next one is called nutrient. Nutrient basically it is toxic to fish. Okay, especially the ammonia. The ammonia they are very toxic to the fish, and also it's kind of it will cause a sick for the newborn baby. Okay, so especially like the nitrate. Actually, there is a medical report which has been reported that when the baby, the newborn baby, when they drink the water containing some nitrate, it will make the baby's skin become blue. So that's why we call this a blue baby. Okay, so this means the newborn baby drink water which contain too much nitrate. Okay, and then so here comes to a metal. The metal, for example, like arsenic or chromium or copper or zinc. This metal, it will cause some disease when people drink the water containing this metal. Okay, so and also it is challenged in agricultural use of the sludge. Okay, and then it will contaminate of the groundwater. And also this metal, they are toxic to human or even to the animal. Okay, and then so it will also inhibit the biological environment because it will kill some bacteria. Okay, next please. Okay, so for the water pollution, basically we have kind of two types of the water pollution. The first one we call is point source pollution. Point source pollution means the pollutant concentrate in one spot. Okay, and then so for the next one is called diffuse pollution. The diffuse pollution means the pollutant is kind of distributed in some ground. Okay, so it's kind of like the area is kind of larger. The contaminant area is kind of larger rather than the point source pollutant. Okay, so let's take the slide, the PowerPoint on the right. For the point source pollutant, the pollutant reach the water points and concentrate in the space. Okay, this is the definition of the point source pollution. Okay, so generally the discharge of domestic and industrial wastewater generate the point source contaminant since the discharge are through outflow. Okay, and then the next one is called diffuse pollution, and then the pollutant enter the water body, distribute at different location along its length. Okay, for example, the stormwater drainage either in a rural area, there's no piping, and then so in the urban area, the stormwater collect system with multiple discharge in the water body. So this is called diffuse pollution. Okay, so usually for the diffuse pollution, the contaminant area is larger. Okay, it's bigger. Okay, next please. Okay, so right now we are moving to the impact of the wastewater discharge to the water body. Next, please. Okay, and then so in this PowerPoint we are gonna have three important topics. Okay, related to the discharge of the wastewater to receiving water body, which is a river, lake, or like a reservoir. Okay, so the first topic is pollutant. The river or lake is polluted by organic matter. And then the second one is contamination by genetic microorganism, which means it's a bacteria. And then the next one is pollution of a lake or reservoir. For example, the eutrophication. The eutrophication usually is caused by nitrogen and phosphate. Okay, so later I will spend a little bit of time on the eutrophication. Okay, next please. Okay, so first we are going to talk about the pollution by organic matter and the stream self purification. Okay, so the self purification is associated with establishment of the equilibrium of the aquatic ecosystem. Okay, after the change induced by the wastewater discharge. So this is like this is a kind of definition of the self purification. And then so the second part, the second one is the ecosystem of the water body upstream of the discharge of untreated wastewater is usually in equilibrium state. Okay, and then downstream of the discharge, the equilibrium between the community is affected, and then resulting in an initial disorganization, followed by a sequent tendency toward rearrangement. Okay, and then in this sense, self-purification can be considered as a phenomenon of ecological succession. Okay, so it means the phenomenon is kind of continuous. Okay, next please. Okay, and then this is the pollution by organic matter and extreme the self-purification. The first one is ecosystem in nature condition. Okay, and then for the ecosystem in the natural condition, it has two characteristics. The first one is a high quantity of species, and then the second one, it has a low quantity of individual in each species. On the other hand, for the ecosystem under disturbance, it has a low quantity of species, and then it has a high quantity of individual in each species, which is these two are kind of opposite. Okay, next please. Okay, and then this is the pollution by organic matter. And then as you can see from the figure on the left, okay. So in this figure, it can be divided into 5 zones. Okay, so as you can see in the bottom of the figure, okay. So the first one is called clean water zone, and then the second zone is called degradation, and then the third zone is called activate decomposition zone. And then the fourth part is called recovery. And then fifth is clean water zone. So basically this 5 zone is corresponding to the figure on the left. Okay, so this is just like a presentation of these figures. Okay, next please. Okay, and then so basically the dissolved oxygen is usually used for the determination of the degree of pollution and the self-purification in the water body. And then so for the oxygen consumption, the first one we call is oxidation of the organic matter. This is also called a respiration process. Okay, and then so the oxygen production is gonna be the automatic reaeration. And then so the second part is called benthic demand, which means the sludge at the deck bottom. Okay, and then so how to have the oxygen to be produced? Usually they use photosynthesis. Okay, and then the next one is for nitrification. Is called ammonia oxidation. Okay, so this is like a 3 oxygen consumption process in the lake. Okay, next please. Okay, and then so in the self purification process, there is a balance between the source of consumption of the source of oxygen production. Okay, so when the consumption rate is greater than the production rate, the oxygen concentration tend to be decreased. Okay, and then the opposite occurring when the consumption rate is lower than the production rate. So as you can see in the bottom, the left side is a changes of the concentration with the time equal the activation plus dispersion plus conversion. Okay, so for the Advection means the transport of the constitute in the velocity field of the field medium. And then the dispersion is turbulent, and the diffusion spread particles of constitute. Okay, and then conversion is biological, chemical, and physical reaction. So basically, these three added up equal the change of the concentration with time. Okay, and then next, please. Okay, and then this is can you go down a little bit? Okay, so this is gonna be the axis along with the spatial and the temporal change of the concentration of the water take place in the river. Okay, and then so let's go down a little bit. Let's move to oxygen consumption. Can you go down a little bit? Thank you. And then so let's first talk about the oxidation of the organic matter. Okay, the organic matter at the first part it shows the organic matter in a suspension which form the bottom sludge layer, and then also need to be stabilized. And then a large part of the conversion is complete under an anaerobic condition due to the difficulty of oxygen to penetrate to the sludge layer. So it means in the bottom layer of the lake, there are so many sludge. Okay, and then so the sludge they are kind of anaerobic because the sludge is so deep of the lake, and then so the oxygen they are not able to penetrate into the sludge. So that's why the bottom of the lake usually is the anaerobic condition. Okay, and then so the second part. However, the upper part of the sludge layer in the order of some milliliter of the thickness still have the access to the oxygen from the supernatant water. This is because the upper side of the lake, it will be a little bit much easier to receive the oxygen. So that's why the upper layer is usually is a anaerobic condition, because the oxygen is able to access into the water. Okay, and then so the third one is the oxygen demand originate from this combined factor associated with the sludge is called a benthic demand. Okay, and then next, please. Into the nitrite, and the nitrate into the nitrate. Okay, so this is kind of the process of the ammonia to be converted. Okay, and then so the microorganisms involved in this process are chemoautotrophics. Okay, which have carbon dioxide as a main carbon source, and which draw their energy from the oxidation of an inorganic substrate such as ammonia. Okay, and then so the transformation of ammonia into nitrite is ammonia plus the oxygen into nitrite, and then you will plus the proton and water and then energy. And then for the transformation of nitrite into nitrate is a nitrite in contact with oxygen, and then you will produce a nitrate plus the energy. Okay, and then so both reactions are oxygen consumption. Okay. And then next, please. And then this is oxygen production. The first one is called osphoric reaction. Okay, and then so the first part is osmotic reaction is the primary factor responsible for the introduction of the oxygen into the liquid medium. Okay, and then the second one is the gas transfer. Transfer is a physical phenomenon. The gas molecules are exchanged between the liquid and the gas interface. So it means the oxygen, it will exchange with the kind of like a surface of the water. So on the surface of water, there the oxygen is gonna be exchanged in this area. Okay, and then so this exchange result in an increase in the concentration in the liquid gas phase. Okay, and then the next is this is what happened in the water body. Okay, and then so so the transfer of the oxygen from the gas phase to the liquid phase occurred through the following mechanism. The first one is called molecule diffusion, and then the second one is turbulent diffusion. And then in the question water body, molecule diffusion prevail. So it means in the question water body, the main mechanism is molecule diffusion. This diffusion may be described as a tendency of any substance to uniform spread itself all over the space. Okay, so however, this mechanism is very, very slow, and it requires a long time for the gas to reach the deep part of the lake. Okay, and then the second one is turbulent diffusion. Turbulent diffusion is much more efficient because it involves the main factors of the effective aeration. So you create the interface and the renewal of interface. And then so the first one is through the interface, let gas exchange occur. And then the second one is the fast renewal of the interface permit let localized saturation points that are not formed, besides the conducting the dissolved gas to the various depths of the liquid mass as a result of the mixing. Okay, next please. Okay, so and then so for oxygen production, the other one is photosynthesis. Okay, so the photosynthesis is the main process used by autotrophic organism to synthesize organic matter, being a characteristic of organism containing chlorophyll. Okay, so the process takes place only in the presence of light. Okay, and then so according to the following equation, the CO2 and water they will convert, so we will produce the oxygen. Okay, so and then so the photosynthesis is a reaction opposite to the respiration reaction. Okay, and then so the photosynthesis is a process of fixing light and form a glucose molecule of the high energy potential, respiration, release of the energy, and the subsequent use in a metabolic process. Okay, next please. And then so the lights manages the distribution of photosynthesis organism to locate to where light is present. And then so when water containing turbidity, so when the water is containing turbidity means there are so many suspended solid in the water. So the light is not able to penetrate. Okay, so for some algae in the water, they are not able to form the synthesis process. Okay, and then so basically the autotrophic conduct much more synthesis than oxidation process, and then generating a positive balance of organic compound that constitute an energy reserve for the heterotrophic. Okay, in addition, an excess of the oxygen that support the respiration of other organisms. Okay, next please. Okay, so let's go to eutrophication of lake and the reservoir. Next, please. Okay, and then I think many of you have already been very kind of familiar with the eutrophication. So in here, maybe I'll talk a little bit faster in order to show you a little bit more information in the following slides. Okay, so the eutrophication usually is defined as excessive growth of aquatic plant, okay, at a certain level to cause interference with the desired use of the water body, as you can see from the photo on the right, as you can see, there are so many green color of the algae on the lake. Okay, so this is kind of like eutrophication. And then so the main stimulating factor is an excessive quantity of the nutrients in the water, mostly nitrogen and phosphorus. The nitrogen and phosphorus is kind of like a natural nutrient source for bacteria or for animal. Okay, and then the level of eutrophication is usually associated with the land use and the occupation in the catchment area. Okay, next please. Okay, and then this is a eutrophication in the lake and a reservoir. And then so as you can see from the figure on the left, this is like a land occupation by the wood and forest. Okay, so when the wood or forest when they fall down, especially when they fall down on the lake, usually sometimes they will kind of like move to the lake body. Okay, and then so sometimes they will be a good food source for the bacteria. Okay, so even in this natural condition and the no-human activity, the lake tend to accumulate solid, less settle, which form a layer of sludge at the bottom. Okay, so this is kind of natural. Okay, and then with the decomposition of the settle material, the level of the nutrient in the liquid mass increased. Okay, so this is a significant increase in the population of aquatic plant. Okay, so this is kind of natural condition to make the eutrophication happen. Okay, next please. Okay, and then so this is the land use for agriculture. Okay, so the removal of the natural vegetation from the catchment area for agricultural use generally lead to intermediate stage in the distillation process of the water body, and that the plant in the basin are harvested and transported for human usage. And then there is a removal of the nutrient that is not naturally compensated and causing a break in the internal cycle. Okay, next please. Okay, and then so in order to compensate this removal and to make the agriculture grow nicely, fertilizer is usually used. And then so the fertilizer is containing the high level of nitrogen and the phosphate. And then so the nitrogen and phosphate, they are kind of good food source. Okay, so the farmer use the high production and therefore added high quantity of the nitrogen and the phosphate frequently, and then greater than the normal farmer used. So actually the high quantity of the phosphate nitrogen accumulate in the lake, in the reservoir, it will cause the eutrophication quickly. Okay, next please. Okay, and then this is for the urban occupation. So a series of consequences, it should be taking place this time at a faster rate. So first, this is a significant increase in the input of the nitrogen and phosphate into the lake, and then cause the increase in population of algae and other plant. Okay, and then so depending on the accumulative capacity of the water body, the algae population can reach the high level, and then causing a series of the problem. Okay, and then next please. And then this is for the urban occupation. So with the high sunshine, the algae can reach a super population because usually the algae, they are kind of floating around on the lake. And then so when they in contact with the lights, they will grow very fast. Okay, and then so when algae they grow too much, and then they will float on the surface of the water, and then you will kind of form a layer, okay? And then so this layer will kind of hinder the penetration of the lights for the lower layer. So it means when there is a layer of the algae on the top of the lake, and then the lights is not able to penetrate. So that's why the bottom part cannot receive the lights. So that's why the bottom part of the lake is usually an anaerobic condition, okay? Okay, and then so the superpopulation of the algae are called algae bloom, okay? Next, please. And then this comes to the problem of the eutrophication. Next, as you can see, the left side is kind of like a before. The right side is like after eutrophication. So basically, when the lake or river, when it become eutrophication, the lake usually looks like a green color. Okay, next please. And then so this is the problem of eutrophication. First, for recreational and aesthetic problem. So the reduction of the use of the water recreation, bathing, and the tourist attraction due to the algae bloom, and then excess vegetation growth, and also disturbance of a mosquito or insect or bad smell. Also, occasionally, fish will die. Okay, so this is kind of general problem of the eutrophication. And also the anaerobic condition in the bottom of the water body, the increase in productivity of the water body caused a rise in the quantity of heterotrophic bacteria, so which fed on the organic matter from algae and other dead microorganisms, and consuming dissolved oxygen from the liquid media. And then in the bottom of the water, it is mainly an anaerobic condition because of the sedimentation of the organic matter and the small penetration of the oxygen. Because in the bottom of the lake, there is very small amount of the oxygen there. So that's why in the bottom of the lake usually is an anaerobic condition. Okay, and then next, please. Okay, and then so with the anaerobic reducing condition occur, and then leading to a compound and the environment being present in a reduced state. Okay, so the iron and the magnesium are found in a soluble form, which may cause problem with the water supply. Okay, and then phosphate is also found in a soluble form and may represent a food source of phosphorus of algae. And then hydrogen sulfide may also cause toxicity or bad smell. Okay, next please. And then occasional anaerobic condition in the water body, depending on the degree of the bacteria growth, total mixing of the liquid mass, or photosynthesis reaction, fish die, and also reintroduction of reduced compound from the bottom onto the whole liquid mass may occur, leading to a negative effect of the water quality. Okay, and then so occasional fish mortality means a fish die, and then so fish die could occur because of anaerobic, and also the ammonia toxicity. The ammonia they will kill the fish. Okay, so in a high pH value, frequently during the period of the high photosynthesis, the ammonia will be present in a significant amount. Okay, so this is a toxic to the fish instead of the ionized form of ammonium, which is non-toxic. And the increase in the operational cost. Okay, and then the next one is the effective the presence of the algae substantially affect the treatment of the water withdraw from lake or reservoir due to the removal of the algae, okay, or also the color removal, or the taste, or the odor removal. Also, it has a high consumption of the chemical product, and also it's more frequently a field backwash, okay. And then so the problem with industrial water supply, because during the eutrophication, there are so many bacteria in the water. So this water is not able to use for industrial manufacturing purpose, okay? And then so it will increase the cost of industrial water supply due to the reason similar to this already mentioned previously, and also the presence of the algae deposit in the cold water. Okay, thank you. Next. And then so the problem of the eutrophication, the one is water toxicity. Okay, so it will kind of damage the water also for the human and also animal supply because of the presence of the toxic material, and also the change in quantity and quality. Okay, and then it will kind of it will have a reduction in navigation, and then transport capacity, and then the excessive growth of the roots, and then microphotocyte interfere with navigation. Okay, and then the next is a negative effect in equipment for energy generation. Okay, and then the next one is a gradual disappearance of the lake. There is an increase in the accumulation of material of all vegetation, and the lake becomes shallow because usually the lake is very deep. Okay, so when the sludge is deposited in the bottom of the lake, so over time, maybe like 10 years or 20 years, okay, the deposit soil in the bottom, it will become more and more. Okay, so you will make the lake become shallow. Okay, and then so this tendency of disappearance is irreversible. Okay, it means it cannot come back. Okay, and then so in the case there is no control in the source or degrading the sediment, the water body could disappear relatively quickly. Okay, next please. And then so here comes to a trophic label. Okay, next. Thank you. Okay, and then in the trophic label, there are there are three types of trophic label. The first type is called oligotrophic. Oligotrophic is just like a clear lake with a low productivity, just like the left side, the upper side of the left image. As you can see, the water is very clean. Okay, and then the second one is called mesotrophic. Mesotrophic means the lake with intermediate productivity. As you can see in the bottom of this picture, the lake has kind of like a some of the area of the lake looks like a green. Some of the area looks very clear. So this is called mesotrophic. Okay. And then the other one is called eutrophic. The eutrophic is just like a lake with a high productivity compared to neutral basic label. So it means the lake is kind of become eutrophication. So as you can see from the image, the lake is all green color. Okay, so this is called eutrophic label. Okay, next please. And then this is the trophic characterization of lake and the reservoir. Okay, and then so the first item is called biomass. Okay, so for the biomass in the oligotrophic, it is very low. However, in the eutrophic, it has very high level of the biomass. Okay, and on the other hand, for the green algae, in the green algae in the eutrophic, it has it kind of so high level. Okay, On the other hand, for the oxygen concentration at the upper level, on the upper level, okay. So for the eutrophic, it's usually is saturated, okay. And then so for the bottom layer, for the eutrophic, it always have a low oxygen concentration in the bottom layer. So actually, this is the differences between oligotrophic, mesotrophic, and eutrophic. Okay, so this is the differences using this table to make the comparison. Okay, next, please. Okay, and then this is the establishment of the trophic label based only on the phosphorus. Is due to mathematical modeling convenience, because for some researcher, they try to predict, they try to model the quality of the lake. They're using a mathematical model, okay? And the reason they only use the phosphate, because the phosphate might be easy for them to predict, okay? So that's why they try to determine the trophic level by using the phosphate instead of the nitrogen. Okay, and then so as you can see from this table, there are 1, 2, 3, 4, 5. There are 5 trophic level. So as you can see, for the total phosphate concentration in the reservoir, for the retrofophic, it has more than 100. Kind of like a ppr, like a microgram per liter. It's kind of like a similar unit, which is kind of high. It usually is higher than 100. Okay, so it means there are too much phosphate in the reservoir, which will cause the algae to grow. Okay, next please. Okay, and then this comes to dynamics of the lake and reservoir. Next, please. Okay, and then so the vertical temperature profile in the lake and the reservoir changes with the season. Okay, so this temperature variance affect the density of the water. So it means that the temperature will change the density of water, and then the mixing and the purification capacity of the water body. Okay, so during the warm period, for example, in summer, the temperature at the surface layer is much higher than the temperature at the bottom. Okay, due to the solar radiation, and then the density of the water at the surface is lower than the density of the bottom layer, which causes the existing of distinct layer in the water part. So it means due to the temperature, you will cause different layer. Okay, so the first one is called epithelium. This is a kind of upper, and then warm. Okay, and then so for the thermal column, this is a transition layer, which is in the middle of the layer. And then the next one is a hypolimon. Hypolimon is kind of as but in the bottom layer, which is cooler. Okay, because the lights is not able to penetrate so deep. So that's why in the bottom of the lake or reservoir, which is usually kind of cold in the bottom. Okay, next please. And then the differences in the density because the complete stratification in the water body, which the 3 layers not mixing with each other. Okay, so this stratification has a significant influence on the water density, and then depends on the trophic level of the water body. A complete or non-dissolved oxygen in the hypomonium can occur. So therefore, in this layer, there will be mostly iron, magnesium, and other compound in their reduced form. Okay, and then in the cold period, the upper layer in the lake is become cool, leading homogenization in the temperature along the depth, which the homogenization of the temperature here is greater similar in the water density. Next, please. And then in the upper layer, suddenly it becomes cold. It tends to go to the bottom of the lake, and then disturb the bottom layer and causing a complete turnover of the lake. Okay, because so the turnover means the lake or reservoir they start to mix. They started to mix together. Okay, so this is called thermal inversion or turnover. This is due to the changes of the temperature. And then because of the change of the temperature, the density of the water change. So when the density of water change inside of the water, then they become kind of circular, okay, kind of mixing, okay. And then in lake, they present a high concentration of reduced compound in a hypomonium. And then the reintroduction of this compound into the lake can cause a huge distortion in the water quality. It will affect the water quality. Okay, and then the decrease in dissolved oxygen due to the reintroduction demand by the reduced organic and inorganic compound can cause a fish die. Okay, next please. Okay, so as you can see from this figure, so the upper side is gonna be the lake with a thermal stratification, which is in warm temperature. For example, in summer. Okay, so in summer, as you can see in the figure on the left side, they are 3 layers. Okay, so the upper side is called epithelium, and then middle side is a thermal microclimate, and then the lower side is hypominium. Okay, so it has 3 layers. Okay, and then so as you can see from the for the bottom image, there's a lake with a mixing thermal inversion, which is cold temperature. So as you can see, there is no layer differences. Everything they are mixing together. Okay, because of the temperature change. Okay, so that's why, as you can see, in the cold temperature, the lake it become kind of the current, the water current becomes circular because of the water density changes. Okay, next please. And then the next one comes to limiting nutrient. Okay, next. Okay, so the limiting nutrient is essential for a certain population. It will limit the growth. Okay, so with the low concentration of the limiting nutrient, the population growth is very slow. And then so with the increases in the limiting nutrient concentration, the population grows fast. And then the researchers suggest the following criterion based on the ratio between the nitrogen and phosphorus concentration in order to estimate the algae growth is being controlled by the phosphate or nitrogen. Okay, and then so for the larger lake, it with the diffusion source, which is the ratio of nitrogen and the phosphate, which is larger than 10. Okay, and then so it's limited by the phosphorus. And then for the small lake, the point source of nitrogen and phosphate source, which is usually smaller than 10. This is limited by the nitrogen. Okay, next please. And then so for most of the trophic lake in Latin America are limited by the phosphorus. And then even if the external input of the nitrogen is controlled, there are organisms which are capable of fixing atmospheric nitrogen. Okay, and then the number of the organism would not be reduced with the decrease in the inference load of nitrogen. Okay, so therefore a larger priority is given to the control of phosphorus source when the eutrophication of the water body need to be controlled. Okay, next please. Okay, so how to this is the estimation of phosphorus low into the lake or reservoir. Okay, so first one is comes to stormwater drainage. Okay, so the area with wood or forest, in this area, phosphorus is low because of the ecosystem is close to equilibrium state. And then for the agricultural area, this is a higher and more phosphate because it depends depending on the soil retention capacity, irrigation, and type of fertilizer or weather condition. So in the agricultural use, because we use lots of fertilizer, and then there are so many nitrogen and phosphate in the fertilizer. So that's why usually in the farm or in the agricultural activity, we always find so much phosphate concentration in the agricultural area. Okay, and then for the urban area, actually in the urban area, why there are some phosphorus in the urban area? Because we use detergent. Okay, so for example, when we use like some detergent to wash our clothes, this detergent has some certain amount of the phosphate. Okay, so when you use the detergent to wash the clothes, your pants, and then so the water goes to the river. Okay, so this water contains so much concentration of phosphate, so it will also make the lake become a eutrophication. Okay, so this is from urban area, and then next comes to the wastewater, and then regarding to the industrial wastewater, the generalization of the contribution is difficult because the differences of different industrial wastewater, even within the same industrial process activity. Okay, next please. Okay, and then this goes to control of eutrophication. Okay. And I have a question. So does anyone need to take a small break? Or do you prefer me to continue?
You need a break. Yes, please, Mr. Rami.
Okay.
If you need to be break.
Actually, for me, I'm okay. I'm fine. It depends on everybody. If everyone wanna take a break, we can take a break, and if everyone wanna continue, we can continue.
Yes, you need to have a drink for a while, for 3 minutes.
Okay. Okay. So how about we take a small break, like 5 minutes?
Okay.
Okay. And then we and I will come. Okay. And we will come back in 5 and at around 10 o'clock, 10 to.
Okay.
Yeah.
Okay. Okay. So I will see you in 5 minutes.
Okay.
Okay. See you later. See you.
Okay. Dr. Chen, please.
Yes.
Okay. For the other participants, please fill in the form, attendance forms in the chat room.
Okay. So you mean there is a form for me to sign up?
For the participants, and also you can sign up the form too. So he put it in the chat room.
Oh, okay. I see.
Okay. So when you see in the chat, please.
Okay, I will come back in 5 minutes.
Okay.
See you later.
See you later. So for the other participants, either students, bachelor students, master students, lecture, please sign in the Google form for the attendance list.
Okay.
For the lecture, just mention the need of the lecture.
Hello. Hello, I'm back.
Hello. Yes. Go ahead.
Okay. Okay. So, can we have the slides, please? Okay. So, can we continue?
Yeah. Okay.
Okay, go ahead.
Okay, thank you. And then so this comes to the control of eutrophication. So the control strategy usually adapts can be classified into two categories. The first one is called preventive measure, and then the second one is called corrective measurement. Okay, and then next please. We are losing the PowerPoints. Okay, thank you. And then so the next one is exportation of the wastewater to another catchment area. So the control of the stormwater drainage, usually the first one is control of the land usage and occupation in the catchment area. Okay, and then so the preventive green belt along the reservoir of its turbine. Okay, and then construction of the phosphate retention reservoir upstream of the main reservoir. Okay, next please. Okay, and then the first one is biological phosphate removal from the wastewater is currently conducted in many countries. And then the process is based on the changes between anaerobic and anaerobic condition. A situation which make a certain groups of microorganisms assimilate a high quantity of the phosphorus than in their usual metabolic system. Okay, so when a biological phosphate, let's take a look at the right side. The phosphorus removal by a physical chemical process is based on the precipitation of phosphorus after editing the aluminum sulfate or ferric chloride or lime. So aluminum sulfate or ferric chloride is usually we use as a coagulant. So usually we added the aluminum sulfate or ferric chloride into the wastewater, and then so they will form complexes, and then they will deposit into the bottom of the lake. Okay. And then so usually this physical chemical treatment after this we can reach about 0.1 microgram per liter. Okay, next please. And then this table shows the corrective method. Okay, so the first one is called mechanical part. Okay, so in here I would I will speak. I will talk about a little bit faster because we still have so many slides in the end. Okay, and then so in here this is for mechanical part. So the first one is called hypolomatic aeration. Okay, so in here we inject the air or oxygen into the bottom of the layer. So it means we added the air into the bottom of the layer to enhance the stabilization of organic matter. Okay, and then the next one is called discharges. Okay, so this is consists of injection of compressed air. So basically, this is the similar method. They introduce the air or oxygen into the bottom of the lake. Okay, and then so the next one is addition of the water with a higher quality. So this is kind of a dilution. They just when the lake is contaminated already, they put more clean water into the lake, try to dilute the lake. Okay, and then the next one is sediment removal. Sediment removal means they try to remove the soil, the static in the bottom of the lake. They try to remove it. Okay, okay, and then the next, please. And then this comes to chemical part. For the chemical part, this is chemical precipitation of the phosphates. So as I mentioned earlier, some researchers they try to add it chemical into the lake, and then so the chemical they will form a reaction with some pollutant in the lake, and then so they will settle down in the bottom of the lake. And then the next one is oxidation of the sediment with a nitrate. Okay. And then the next one is gonna be application of a herbicide. The reason they added herbicide into the lake because they wanna avoid the vegetation growth. They wanna reduce the vegetable to be grow. Okay. And then the next one is application of a lime. So they added the lime into the lake. They try to kind of infect the bacteria, okay, to reduce the algae. Okay, the next, please. And then here comes to biological part. Biological part is first they raise the fish, they feed on the plant. So it means they try to grow more fish in the lake, and then so sometimes the fish they will consume some maybe some nutrient in the lake. Okay, so when the fish consume the nutrient concentration will become low, so the water become clean. Okay, and then so let's move to the next. Okay, so this comes to a quality standard for wastewater discharge and the water body. Okay, and then there are 3 types of the standard or guideline for wastewater discharge. The first one is discharge standard. The second one is quality standard for receiving water body. And then the third one is a standard or quality guideline for a certain use of the treated effluent. Okay, next please. Okay, so right now here comes to a consideration about the development of discharge standard in developing country. Okay, next please. Okay, so right now this is kind of some developing country. They have sometimes they have some problem when they try to establish a standard for wastewater treatment or for the wastewater treatment discharge. Okay, so first one, the problem is guidelines are directly taken as national standard. So it means so how it should be. First, each country should adapt the guideline based on local condition. Okay, for example, in the United States, the United States is so large, and there are so many. There are about 51 states in the U.S. So each state should have their own regulation. Okay, because each state they have their own weather or their own cultures. Okay, so that's why it says each country should adapt the local condition. Okay, then the next one is a guideline value are treated as absolute value and the target value. Okay, so how should it be? How should it be? It means that guideline value should be treated as a target value depending on the country's technology process or financial condition. So it means sometimes the government, they set up a regulation which is too strict, and then but we don't have that technology try to meet the regulation of the government. Okay, the next please. Okay, and then the problem is another problem is standard are frequently copied from developing countries. So it means sometimes the company sometimes the local government they just copy the regulation from other countries. So it means actually this regulation doesn't fit your local situation. Okay, so in order to make the regulation, you need to come up with the regulation which is very close to your environment. Okay, and then the next is some standards are excessive strict or excessive relaxed. Okay, so it means some standard they might be they just too strict or some relaxed. So it means they don't make the middle part of the guideline. Okay, next please. Okay, and then the other problem is there is no affordable technology to lead to a compliance of the standard. So it means sometimes in some developing country, they don't have this type of the technology, or this wastewater treatment technology is too expensive. That company cannot afford it. So it means if you set up a regulation which is or some technology requirement which is too ideal, then some company they are not able to follow. Okay, and then so the next one is the standard are not actually enforced. So it means even though the local government or our government they establish a regulation, but the local police or local agency they didn't follow. They didn't take this seriously to enforce this regulation. So actually it doesn't work. Okay, the next please. Okay, and then so this is a low standard value are sometimes below instrument detection limit. So it means every instrument it has its own standard. It has its own detection limit. For example, for GC, the gas chromatography, the detection limit, for example, which is maybe is a 1 ppb, is a microgram per liter. And then so if you set up a regulation which is below the detection limit, then it means that the instrument cannot measure that concentration. Okay, so actually it doesn't work. Okay, so next please. Okay, and then this is the possible discharge standard according to the different level of stringency for the main pollutant in domestic sewage. Okay, so for the first one, for the BOD, usually for stringent usually, which is about 20 to 30, and for COD, which is about 100 to 150. And then for the SS, the suspended solid, which is about 20 to 30 milligram per liter. Okay, so this is just a common discharge standard for developing country. Okay, next please. Okay, so and then this is the WHO, the World Health Organization guideline for the reuse of treated wastewater in agricultural irrigation. For the category A, for the reuse condition, the irrigation of crops likes to be eaten uncooked. Okay, so it means this type of irrigation water quality has to be perfect, has to be very clean, because people just eat the vegetable just without cook. Okay, so for the category A, the water has to be very clean. Okay, next please. Okay, okay, so right now we are moving to another topic, which is called a circular economy. Okay, so for the circular economy, can you please click the picture? There is a link. Can you yes, please click and there's a link. Okay, can we take a look at this video?
Life is a circle. All that grows returns to where it began, the air. And from there, it grows again, forming a perfect cycle. But we have broken that cycle. Our economy is growing unsustainably at the expense of nature. We have created a linear economic model. Make, use, dispose. We extract millions of tons of natural resources every year and turn them into materials that we use and consume. And then we simply throw them away. But what if we designed products that we can reuse, refurbish, and repair, and only extract new resources when we really need them? We would use less new materials and energy and protect our natural wealth. Inspired by nature, a circular approach would boost the European economy, contributing to innovation and job growth, as well as reducing pollution and helping the environment by preserving our precious natural resources. Carpooling, recycling materials, repairing and reusing, using green energy. Many things we already do are part of going circular. A circular economy is possible and brings new opportunities. And it isn't just good for nature and the economy, it's good for our quality of life and our health. A circular economy is a good way of living well within the limits of our planet.
Okay, thank you. Okay, so basically this is like a kind of a circular economy. And then so what is a circular economy? A circular economy is an economy system. It's aimed at eliminating waste and the continual use of the resource. So it means when we generate the waste, and then we try to recover it and then reuse it over and over again. So it means we don't discharge the waste to our environment. Okay. And then so this is called circular economy. And right now in Taiwan, this kind of topic is very popular, especially for environmental engineering. Okay. And then so for today, I will just give you some brief introduction of what is a circular economy. And then so for the next class, I will show you some circular economy specifically in wastewater treatment. Okay, so today I will just give you some briefly background introduction. Okay, so maybe I will go a little bit faster. Okay, and then and the circular system employ the reuse, sharing and repair, refurbishment, remanufacturing and recycle to create a closed loop, and then minimizing the use of a resource input and the creation of the waste, pollution and carbon emission. Okay, and then so the circular economy aims to keep the product, equipment, and the infrastructure in the use for longer, therefore improving the productivity of this resource. Okay, next please. Okay, so what is the differences between the linear economy? What is the difference between the circular economy and the differences between the linear economy? So the figure on the left, on the left is called linear economy. The linear economy means, okay, for example, we take the resource and then we take a resource from our environment and then we make it to make the product. And then so when we use the product, we dispose of. So it means that we use the natural resource and then over and over, the natural resource will become less. Okay, and then so the figure on the right is the circular economy. The circular economy, just for example, first when we have a natural resource, we make it, and then we use, then we recycle, and then when we recycle, we use it again. Okay, so this is just like a circular. So this is called circular economy. Okay, so it means that we try our best, try not to dispose, try to not to create a waste. Okay, we try, when the waste is created, we reuse it, we recover it. Okay, the next please. So how do the material circulate in the circular economy? So the first one is a biological circle. The second one is called a technical circle. Okay, next please. Can we go next, please? Okay, so how do the circularity related to sustainability? Okay, the sustainability means we try to make a thing goes longer. Okay, try to make it very constant and stay longer. So the first one, the circularity can contribute to a more sustainable world, but not all sustainability contribute to the circularity. Okay, and then the circularity related to the resource recycle, while the sustainability focus to people, the planet, and economy. Okay, so it means the sustainability, we care about people and environment and the earth. Okay, and then so the circularity and sustainability represent a long tradition of relative virgin model and theory. Okay, next. Okay, so what is the disadvantage of the current linear economy? The first one is ecological disadvantage. Okay, the first one is the linear economy is the production of the product at the expense of the productivity to our environment. Okay, so it will cause excessive pressure on this ecosystem, endanger the provision of the essential ecosystem service such as water, air, or soil. Okay, and then so I will just mention some important part in the slide. Okay, so the rest of the information maybe you guys can take a look by yourself. Okay, so next please. Okay, so as you can see from this picture, I think everybody see the picture when you see the news. Okay, so as you can see from the left, there's a turtle. The turtle has been trapped by the plastic, right? And then as you can see in the bottom of the picture, there are so many plastic bottles on the river or even on the ocean. Okay, so this is kind of this is kind of disadvantage of the current linear economy. Okay, because we produce the waste, we didn't recycle, we just produce the waste and then throw it away, and then so it means this is why we have plastic contamination. And right now in our department, some of the professors, they are trying to working on this project. They try to use their technology or their method, try to remove some of the plastic contaminant in the ocean. Okay, the next please. Okay, so what and then so there's another disadvantage. As you can see, the micro beads, as you can see the toothpaste, there are many small bean in the toothpaste, right? So actually the small bean is going to help you to make your tooth looks more bright, but actually this kind of the microbean, it is non-biodegradable. It means the microbean will stay forever in the plant. So when we use this kind of product, sometimes you will kind of swallow, right? So sometimes when you brush your tooth in the morning, sometimes maybe you will kind of swallow a little bit. Okay, and also with a longer time when we use this kind of product, actually when it goes to the wastewater treatment plant, we are not able to treat this type of particle because it's too small. And then so this kind of particle, they will go to the ocean. Okay, so it will kind of further polluted the ocean. Okay, next please. Okay, and then so the second one is for economic disadvantage. Okay, so first it will fluctuate the raw material price. It will make the the material price become up and down, up and down. Okay, you will kind of change the price. So this is another business. This is kind of a business aspect. Okay, the next one, please. And then the next one is gonna be material scarcity, because the material is kind of natural resource. Okay, so we were not able to produce this kind of material. So when we just keep using this material, someday we won't have this material anymore. Okay, so this is the disadvantage of the economic disadvantage. Okay, next. And then the next one is called interdependence. Okay, so due to the increase in the trade activity, the geopolitical interconnectedness of the product become increasingly strong. Okay, next please. Okay, and then so what is the benefit? So right now we are talking about the disadvantages. So what is the benefit of the circular economy? Okay, so it will increase the economy growth, because for example, the United Nations Environmental Plan, they predict in 2050 the global economy will benefit for more effective resource used by 2 trillion a year. Okay, next please. And then this is gonna be innovation stimulus. Okay, so circular economy enhance the cutting edge solution based on a new way of thinking. Yes, because in order to recover this material, we need to think about a new technology. So the circular economy will kind of encourage the researcher try to develop new technology in order to recover the material. Okay, next please. Okay, and then so we will have less greenhouse gases. Okay, so it means our sky will look like more blue, and then we will be able to breathe the clean air. Also can make you feel healthier. Okay, next please. Okay, and then so what is the other benefit? We will have a clean soil, air, and water. So it means people won't get sick easily. Okay, because actually in Taiwan right now we also have some like wastewater treatment problem, because some of the company or industrial they just try to discharge the wastewater to the river directly without wastewater treatment process, without using a wastewater treatment process. Okay, so it is kind of damage our environment. Okay, so the clean soil, air, and water is very important for us to live. Okay, next please. Okay, and then so the next is we are able to conserve the natural resource, because as I mentioned earlier, the natural resource will be used up one day. Okay, so we need to conserve this natural resource, okay, for other important purposes. Okay, next please. Okay, and then so what is the benefit for the business? They can make more money, they can make new profit. Okay, so the transition to the circular economy, companies are reducing material cost and developing a new business market. Okay, so this is good for business people. If they follow the circular economy process, they are able to make money. Okay, next please. Okay, and then so we will have the business people, they will have a stable material supply because we try to recover the material. So it means we will have material over and over without try to find a new natural resource. So we will have a stable material supply because we try to recover it. Okay, next please. Okay, so this is gonna be the reference I use for this PowerPoints, and as I mentioned earlier, and also this first class I just give you some basic information about like a circular economy in our environmental aspect. So for the next week, I will for this Thursday, I will give you a little bit more specific, like a circular economy in wastewater treatment, which I will give you some more example. So what does other country are doing? So you can get some information about circular economy. Okay, so this is gonna be the class for today. Okay, and then so this is just try to show you some master program in environmental engineering in our department. Okay, so usually students are taking class in the first and second semester. So it means they are taking class in the first year. Okay, so for the first semester, they are taking like a special topic seminar. The special topic seminar means like we will invite some researcher, invite them to try to have a speech, try to share some of their experiences to us. Okay, and then so we will also have a research method, and then we have environmental physics chemical treatment, which is a required class because this class is very important for engineering students, environmental engineering students. So that's why we will for the first semester we have this couple class, and for the second class we also have a similar class, but we will have environmental biological treatment class. Okay, this is also a required class. And then next, please. Okay, and then so this is an elective subject. So for example, we will have a water chemistry or some soil chemistry, or like a green and green environmental planning. So this is all the elective subject. This is based on your interest. If you are interested in some classes, you can choose the class and then just go to the class and then try to learn something from the professor. And then so in our department for the master degree, the total credit requirement is about 30 credits. Okay, and then so for the required courses is 12 credits. And then for the elective courses is 18 credits. So after you finish all these credits, and also when you pass the oral presentation, then you will get a master degree from our department. Okay, so this is for the class for today, and I hope you enjoy the class. Okay, thank you for listening. Thank you.
Okay, thank you, Professor Chen. Okay, so now it's 9:38. I think.
Right.
Yes, I think because of we will have another meeting class on Thursday. Could the discussion in the next meeting so we can
sure.
go on with the closing this session. Because I'm afraid because it's too late to you to go to your home because we have a different time zone, 1 hour. So now most of the participants are in the home. So
I see.
So now in Pekanbaru the time is 9:30.
Right.
So I think in the Taipei it should be 10:39, right? Almost.
Right.
Okay.
Right. Okay. Yeah. Sure. We can have like a discussion for the next class. I will save some times for the group discussion. Yeah.
Okay. Great. Okay. Okay. I will check. I will stop the share, and then I will
Yeah, sure, sure.
the chatting room.
Okay.
Okay, I will check if it's for the comment of the. Okay,
Mhm.
so from Dr. Idra Amri, he said that we have a little problem regarding the groundwater zone. Riau province having 3 groundwater zone actually. The problem is 3 ground zone that found before all in Riau province area. So the company get permit approval is only get approval in government in Riau government only. From the 2018, the one zone passed the other province. So that permit approval should be signed by central government. The question is that possible? The groundwater zone expands to the area, to the two other area, even they are highest position than Riau province. And then
Okay.
I also asked the student to, I will put all the question in the
Mhm.
Microsoft Word, and then I will send
Mhm.
in the Google Classroom.
Classroom. Okay, I see.
Okay, so
Okay.
everyone can read the question, and also we can discuss it in the next meeting. Okay,
Yeah, sure. Thank you.
this is
Thank you
the
very
best
much.
solution for this time. Okay,
Okay, got it. Thank
so
you.
I would like thank you to everyone. So the participant is more or less 50 participants. So from the
Mhm.
students, lecturer, and also from the international office member. So it's really great thing that we can do the joint course together. I hope all the participants enjoy it. So every time we will evaluate it if we can solve the problem or we can make it even better. Okay. Okay, thank you very much for the attending for the Vice Rector Professor Saiful Bahri.
Thank you, Mr. Kamiza.
Okay, thank you. And thank you very much for Professor Dr. Ching Lung Chen or Dr. Professor Tommy. Thank you. Thank you for your
Thank you.
effort,
Thank you
for
very
your
much.
time, and also for your
Thank you.
knowledge and sharing to our students, both bachelor and master students. And thank you for the head of master student, Dr. Idra Amri. Thank you.
Yeah, thank you.
And thank you for the head of the program, engineering, for the environmental and also chemistry engineering, Dr. David and Dr. Zul. Thank you. And also I would like to say thank you to our lecturer that participate in this program. Thank you for our beloved student from bachelor and also from the master students. I hope you can enjoy it and then see you next time.
Yes.
Okay, so you can leave this program. Thank you.
See you next time. Thank you
Thank you.
so
Have a
much.
nice time.
Thank you, Bu
Thank
Fitri.
you.
Bye-bye.
Okay, thank you. See you next Thursday.
Three.
Ya, Pak.
Maybe for students who didn't fill the absent or class attendant today, they can fill the absent until 12 o'clock p.m. in the classroom. Because we put the absent in the Google form in the classroom. And also for the lecturer, we all remove their role as a student, and we are re-invited into the classroom as the teacher role. Yeah, please accept, check your email, and then accept the invitation and open the invitation in the classroom. Okay, thank you. Meeting now.
Oke, Pak Hendra bisa copy pertanyaan para partisipan ya?
Boleh, nanti saya download nanti ya, saya kirim nanti di chatnya.
Oke, di chatnya, ya. Oke, minta tolong ya Pak Hendra.
Ya, nanti saya kirim via email ya.
Oke, terima kasih. Oke, terima kasih semuanya. Ada David, terima kasih. Dwi, terima kasih. Enrico, terima kasih.
Sama-sama, Bu.
Mikhail, selamat, terima kasih. Dwi Afrianti, terima kasih. Budi, terima kasih. Dedi Sutendi, terima kasih.
Sama-sama, Bu.
Pak David, terima kasih. Rika Permata, nah ini yang istimewa ini. Rika Permata ini student di MCUT University. Terima kasih Rika. Oke, izin leave meeting ya. Sampai jumpa di hari Kamis.
Bu. Thank you.